Hello everyone and welcome back to another video. This is our second video on section 6.1, the multiplication and division of rational functions. And in this video what we're going to cover is how to simplify rational functions and how to determine what their domains are. So I want to bring careful attention to an important fact, and that is that let's suppose that we have a rational function that looks like this. Let's suppose it's x squared minus 1 divided by x plus 1 times x plus 2. Let's say that we're given a function f of x equals this. All right. Well, the first thing we want to do when we're simplifying rational functions is to factor them and to see whether we can cancel factors. And we have to be careful when we're canceling factors. So this is a difference of squares, and recall that this is a squared minus b squared, and it becomes a plus b times a minus b. So a is x, so it's x plus b, x plus 1 times x minus 1. That's the top. Review a factoring video, the factoring video on the difference of squares, if that's puzzling you at all. And below, we still have x plus 1 times x plus 2. Now, it's very, very tempting to just say that this equals x minus 1 over x plus 2. And that's fair. It's a little bit informal, though. And here's the reason why. Let's suppose that we just rename this function g of x. Let's say that we have g of x is x minus 1 over x plus 2. So I'm going to erase this for now. But let's just suppose that we had another function g of x with this as its numerator and this as its denominator, x minus 1 over x plus 2. It's basically the simplified version of this, right? Well, let's consider the domain of f to begin. The domain of f. Well, the domain of f would be all values that we can plug into the function. And remember, the big potential red flag would be if the denominator were to equal 0. So in this instance, the domain of f is all real numbers. I'll say all real numbers with that symbol r, except x equals -1 and x equals -2. And that's because if we plugged in either -1 or -2 in, we would have 0 times something, or we would have 0 times something. So either way, we would end up with a 0 in the denominator. And remember, you cannot divide by 0. That's a fact of math because it's not well defined. So anyway, to summarize, the domain of f here is all real numbers except -1 and 2. So that's the domain of f. Now let's look at the domain of g. Well, the domain of g should be a little bit bigger because the domain of g only has one value where we cannot evaluate the function. So that value is all real numbers, or sorry, what I mean is that value is -2. And so the domain of g is all real numbers except x equals -2. So notice, this can be simplified to this, right? We could cancel these factors out. But just remember that the domain of f should not change because we still have these two in the bottom. So we still are unable to plug in -1 or -2. So f and g here, in other words, are not the same function. So I'll say f and g are not the same function. So that's just kind of a note of caution. When you're finding the domain of a function, do not simplify it before finding the domain. Just leave it as it is. So leave it as x plus 1 times x plus 2. Determine where either of those are 0, which in this instance it was at -1 and -2. So the domain of f is all real numbers except -1 and -2, but for g, it was all real numbers except -2. So I think that's all I'm going to talk about for this video, but maybe in the next video we'll get into some more simplifying rational functions. I didn't want to harp on this example for too long, but it is really important that when you're finding the domain, so I'll actually just write this out just so you guys have it. When finding the domain of a rational function, comma, determine where the denominator is 0 before simplifying. All right, that's it for this video, guys. I just wanted to stress this note really hard before you get to your online homework and before you get to the written homework for me in the future. So we'll see you guys in the next video where we cover some more simplification and we cover a slightly faster way of simplifying rational functions by canceling factors. So we'll see you guys in the next one and have a terrific day.